in 1972 when my husband's parents, we were newly married, and our husband's parents took us down to Valdez. And then I remember a 400-foot wall of ice, like right in front of us, with all this ice cabin on it. Well, when we went this weekend, the place where we saw the glacier is now completely underwater. It's under 30 feet of water. Then you travel maybe 10 miles, and however much up to the bay, and there's 400 feet of water. And you never get close to the glacier. I mean, I was amazed. So I'm looking forward to Tom's talk tonight, because I know we're going to see other amazing things.
So thank you, everybody. I had a title. It was something about ocean motions around Alaska, and I left my coffee cup outside last night. And what happened last night? It rained. And so when I brought it in today, and I'm drinking my rainwater, I thought, where did that rain come from? So I thought what I would do, part of my job as an oceanographer, is to figure out how fast things move around in the ocean. So, and I work with people that study the atmosphere and the winds, and I also work on occasion with people that study rivers. So I thought maybe what I should do is talk about water and how it moves around the Earth, but in particular, how water moves into Fairbanks and out of Fairbanks. Okay? So that's what I want to do for a while tonight.
We're going to turn your lights on just a second.
Okay.
I was premature. Just turn them on. Oh.
We have a glitch? Okay, all right. So what I want to do is first ask, where do raindrops or snowflakes that land in Fairbanks, I want to tell you where they come from, okay? And then I want to talk about where they go. And then I want to give you an idea of how long it takes to go from one place to another. Okay? So maybe, I don't know, maybe I can get an assistant. Is there an assistant in the audience? Young lady, would you like to be my assistant? Okay, you don't have to be my assistant, but, oh, would you like to be my assistant? Thank you. Okay, I want you to operate this, okay? The mouse, can you operate a mouse? Okay. So, we're going to start out with, what is this? Anyone have any idea what this is? A map. She said a map. If you're going to be my assistant, maybe. What is your name?
Aaron.
Aaron. Okay. So, Aaron, on that map, can you use the mouse to point out where Fairbanks is? I give you a hint. Right there. Okay. Okay. So now, the first question we're asking is, where does the water come from that lands in Fairbanks? All right? Well, it depends upon the time of the year that you're talking about. Push it down. Yeah. So, in the summer, right now, most of the moisture and rain coming out of the sky originates down. You know what this area is called? That's Indonesia, Northern Australia, the Indo-Pacific region, right along the equator. area where there's a lot of evaporation. Does everyone know what evaporation is? Okay. If we take liquid water and we make it a gas, what's that? Yeah.
What is that?
Say Pacific Ocean and East Asian seas.
Pacific and East Asian seas.
Very good. Okay, so that's the spring and the summer. Can you push that arrow again? In the winter, moisture comes out of the ocean off of Japan and is carried into Alaska. That's our snow. So those are the regions where we get most of our moisture. Okay? Could you push that arrow again? It only takes about 2 or 4 weeks for that water to evaporate and come up and dump in Alaska. 2 to 4 weeks. Okay, the next thing. Okay, so what happens to the rain or snow after it lands in Fairbanks? Well, some of it lands in Tom's cup, and he takes a sip. But push the arrow again. Chena River. Does everyone know the Chena River? Okay, so this too is a map. And all those little blue squiggly lines are all the different streams and rivers that run into the Chena River that ultimately comes through town in Fairbanks. Okay? So, comes and drains a big, big area. Push the next arrow. So how long does it take to flow down the Chena River? Well, it depends. You know, if it gets locked in the snow, it stays there for a long time before it melts. So if it comes down, lands in the river. But we'll give you an estimate. Push the arrow, please. It takes 1.5 to 2 years to come down off the mountains and the hills surrounding Fairbanks, enter into the Chena River, and come through town. All right? Next arrow. Anyone know where it goes after it gets in the Chena River? Who? Who said that? I heard the right answer. Who said that? Everybody. Okay. Push the next button. Okay. So, can you show everyone where the town is? So, it enters the Tanana River. My assistant is showing you where the Tanana River is on that map. Okay? And you push the next button. How long does it take to flow down the Tanana River? Anyone have any ideas? Well, let's give them the answer. It takes about 3 months. Okay? So goes down the Chena, enters into the Tanana. Where does it go after the Tanana? Yukon! That a boy! All right, go. Okay, we got the answer already. There we go. So there's the Yukon River. Can you use the mouse to show where the Yukon River is? Yep. Goes all the way up into Canada, way up into northern Canada, western Canada. And where does it wind up emptying into? Bering Sea. Bering Sea. Thank you. And it enters in right across from Norton Sound from the city of Nome. Okay? Can you push that button? How long do you think it takes to flow down the Yukon once the Tanana, from the point where the Tanana enters? 2 weeks. 2 weeks. Any other takers?
1 month.
1 month. Push the button, please. I think it takes about 3. Okay? Okay. Yes, ma'am.
How do you know all these? How do you know?
And they load up. Well, that's a good question, but maybe we can work on that later. Okay. Push the next one. All right. So when it gets down the Yukon River, it goes into the Bering Sea, you said, right? So where does it go from there? Well, those little arrows on this map showing you the direction of marine currents. Okay? And this is work that I've spent with my colleagues at the University of Alaska. Spent a lot of my career trying to figure out some of these errors. So, it comes out of the Yukon River. Can you show where the Yukon River? Okay. Comes out of the Yukon River, enters Norton Sound, and starts to head north. And it heads north to a really important passage called Bering Strait. You push the next button. And it takes about 1 year to get from the mouth of the Yukon River all the way to the northern edge of the Chukchi Sea. It's about 500 miles. Next button, please. If you were walking as fast as the current is flowing, from here to Fred Meyer's to get a snack, it would take you 3 days. Okay? So it takes about 1 year to get from Norton Sound across the Chukchi Sea. Moving really slow. If you were really hungry, you would have a big problem getting to Fred's. Okay. Next one. So here is a satellite image of Bering Strait. So let's just see if everyone knows. This is Alaska over here. Okay. This is St. Lawrence Island. This is Siberia. Here's Little Diomede Island right there. There's Big Diomede Island right there. Right down in between it is the convention line that separates the United States from Russia. And way over in the corner over here and off the screen is Norton Sound, and further south is the Yukon River. Now, if you look at this picture, you see that this water is brownish, right? That water is coming out of, includes a lot of Yukon River water. And we all know that the Yukon River is really muddy and murky, full of glacial silt, and you see it in the satellite. And here it is, hugging along the coast of the Seward Peninsula, coming right up around the very eastern side of Bering Strait, right off of Cape Wales, and heading north. Okay, so let's summarize what we've done so far, okay? So we've taken our drop of water, and summertime, let's say, so we've been evaporated somewhere off of Indonesia, carried into the atmosphere, and we've come over to Alaska, and we've rained down. Okay? Taken us somewhere in the order of a month. Then we've gone from the Chena River to the Tanana. That's taken us about a year. Tanana to the Yukon, about 3 months or so. Yukon to the Bering Sea, about 3 months. Now we get in the ocean, and we cross the Chukchi Sea right on the edge of the Arctic Ocean, and that's taken us a full year to do that. Okay? So one of the things that we can conclude, maybe, is that the atmosphere moves water pretty fast. Rivers move water somewhat fast. Oceans seem to be moving water pretty slow. Next one. All right, now we're on the edge of the Chukchi Sea. We want to know where our water goes next. So here is a picture of the Arctic Ocean. And let me work this, okay? So, our river water came out right here, went up through Bering Strait to the edge of the Arctic Ocean, and it goes across the Arctic Ocean into the North Atlantic, either between Greenland and Europe, or down through the Canadian archipelago and Greenland. So, it kind of goes through some convoluted patterns in the Arctic Ocean. There are gyres, and there are looping currents. And it takes about 10 years to get across the Arctic Ocean, no matter which pathway you drive. On average, it takes about 10 years to get across the Arctic Ocean. So that bar that I put in the middle of this map is about 3,500 miles. And if you were that person walking at the same speed as a water particle moving through the Arctic Ocean, it would take you 5 days to walk from here to Fred Meyer. Okay? That's how fast, on average, it's going. It takes, on average, about 10 years to get across the Arctic Ocean. Any questions? Now, I'm not going to talk about, yes, sir.
You're talking about the flow and how long it takes, so I can also visualize it. If I just was in a little raft or whatever, and I just was on the water, and I just let the current take me, that's how long it would take me.
On average, yeah. So if all of us got in that same little tub that you just talked about, and put you all on the edge of the Chukchi Sea, about 10 years later, we would hope to see you over here somewhere, okay? Or maybe down here, okay? So if you're going to do that, you're going to have a big tub of food and other things. Okay? So I'm not going to talk about this today. I'm only talking, yes, sir?
Does that mean that when you're starting on the left-hand side, you go that way and you freeze, because it's winter time, that the ice itself is gradually moving left to right?
Well, that's a really good question. What I want, yes, in fact, the ice generally moves out of the Arctic Ocean down into the North Atlantic. But we're going to just stay a liquid molecule, and we're going to be in the upper layers of the Arctic Ocean, and it generally is doing the same thing as the ice. Now, I'm not going to talk about it today, but there's another fascinating side of the Arctic Ocean, and that is that the Atlantic water flows from the Atlantic Ocean into the Arctic Ocean as well. And the very deep portions of the Arctic Ocean are filled with water that came from the North Atlantic. I like to tell the folks when I'm up in Barrow that if they were to take a deep dive off the edge of their beach and go down about 700 feet, they would dive through first the Pacific Ocean, and then they would dive into the Atlantic. So that is a unique community because they have the Pacific and the Atlantic Oceans right outside of them. Okay, next slide. So the Chukchi to the North Atlantic Ocean takes 10 years. Okay? What happens next? Now, our raindrop went from Indonesia, Fairbanks, out the Yukon River, into the Chukchi Sea, across the Arctic Ocean. It's in the North Atlantic. What happens next? That's what we want to explore. Next question. So, there's two different pathways. Let's go back to one. So here's Greenland, okay? In the next map, I'm going to show you just this part around southern Greenland and eastern Canada. So one pathway that water molecule will take is to go down along the east coast of Greenland. It comes whipping around Cape Farewell, the southernmost point of Greenland, up into the Labrador Sea, comes around Baffin Bay, and it gets joined by water that's coming through the Canadian archipelago, and it comes down the east coast of Canada all the way down off of Newfoundland, and even further south. And as it's going down, some of that water is peeled off and enters the North Atlantic Ocean, but some of it comes all the way down to Cape Hatteras, North Carolina. Everyone know where North Carolina is? Yeah. All right. All right. Okay. And then eventually that water off of Cape Hatteras gets swept into the Gulf Stream and carried out into the big ocean. Probably takes about 10 years or so. Okay. The other pathway is really pretty fascinating. Okay, the second pathway, I think I got a problem here. Let's just ignore 3 years to get to Freddy's. I think that's on the wrong one, all right? So the second pathway is really kind of cool. Comes out of the Arctic Ocean, and it sits up here in the Greenland, Iceland, Norwegian Sea, and it gets cold and it sinks. It sinks to great depths in the North Atlantic Ocean. And what it does is it sinks and it starts to flow down. And I'll show you in a second what's happening. It flows all the way down, very deep, down past South America. And then it turns to the east and starts to flow around Antarctica. And then it comes up into the North Pacific Ocean. Gradually, eventually, it comes up to the surface. Okay? So, it sinks in the North Atlantic, and it comes back to the surface in the North Pacific. And it takes about 700 years. Okay? And that would take you, at that rate, it would take you 3 years to walk from here to Fairbanks. Okay. All right, so now let's sum up. Our water parcel left Indonesia, took a ride on the atmosphere up into Alaska. That took about a month. From the Yukon River to the Bering Strait took about a year and a half. Okay? Crossed Chukchi Sea in 1 year, crossed the Arctic Ocean in 10 years, and it went through the Great Ocean Conveyor Belt, that's sinking and subsequent surfacing, 700 years. So our parcel of water, 712 years and 7 months to do what we just described on average. Okay? And then we start all over. So, next slide. So, you know, what happened 700 some odd years ago? So that water parcel sunk in the North Atlantic Ocean in the year 1330, and that was about the time of the beginning of the 100 Years of War between England and France, when we were using swords and banners and armor when we were doing our fighting. So the last time that molecule of water got any news was around the 100 years ago. Okay, young lady. Next one. Okay, so that is a map again of the Great Ocean Conveyor Belt. And now I want to show you something that we use ships to make measurements continuously around the global ocean. We put these together. This is the way we can start to make the story that we just told you. Okay? So this map is the same one we just had, but I'm going to show you data that's been collected by ships that runs all the way from just off of Iceland all the way down to nearly Antarctica. And I'm going to show you what we call the vertical section. And it's going to show you salinity as a function of depth, latitude. I'm going to show you oxygen in the water as a function of depth and latitude. Okay?
Can you get a chair for your nephew?
Oh, yeah, thank you. Okay, so let's look at this. This is the depth axis. This runs from 0 to 6,000 meters, about 18,000, 19,000 feet. Okay, that's the vertical scale on this axis. So that vertical scale is greater than the Alaska Range to the south. Okay? The black stuff all along here, that's the bottom of the ocean. And you see that there are mountain ranges and ridges all along the bottom of the ocean. The bottom of the ocean is not flat. Okay? And then the colors in this top panel are salinity, or the amount of salt in the water. And the reddish colors mean there's a lot of salt, and the bluish colors mean not too much salt. Okay? And I've drawn a red line that indicates this is the water that came out of the Arctic Ocean, and it has sunk and has started to move southward in the North Atlantic Ocean, way to the south, eventually all the way to Antarctica. And you can kind of see that in this tongue. In this tannish tongue. That's relatively low salinity water. Okay? So that's sinking in the North Atlantic. The same process happens in Antarctica. Down on this end, and this water is even colder and more dense, and it sinks even greater, and it flows up into the North Atlantic along the bottom. Okay? We can also see that in the deep North Atlantic is this region, this purple color. That means it's rich in oxygen, and that water left is in close contact with the atmosphere and then sunk into the bottom of the ocean and starts moving around. Okay? This yellowish color, that's low oxygen water. Okay? So at our poles, or at our high latitudes in both the South Atlantic and the North Atlantic, we have water that is cold and it sinks to the bottom of the ocean and it establishes this great ocean conveyor belt. Lots of years were spent in putting this data together. Okay, so now I want to shift gears and I want to show you a couple other things. And I'm going to show you, you might have heard that the University of Alaska has just started to operate a new research vessel. That vessel is called a Sikuliak. And it's an Inupiat word for young ice. And I'm going to show you some pictures of it breaking young ice in a second. And the way this vessel works is that oceanographers from all over the country can use this vessel. So, I think we can go to the next one. So what I'm going to show you is in March of this year, the Sikuliak went from Dutch Harbor up to about St. Matthews Island and did some work in the ice. I'm going to show you a little video of that working in the ice. And I think we are done with this. Oh, we got to go. We'll go back to that one later. He is cute. Okay, so now what I want to show you is uh-oh. I might need your help. I just want to make sure it's on maximum volume. Oh, that's what I have to do. Okay. Okay, so we're gonna first start out this little video. This is gonna be from the perspective of the bridge moving through the ice, and it's pretty thin ice. And in order to make this go fast, we've speeded up the video. So the boat really is not moving as fast as it looks. Okay? And hopefully we have volume. Oh. It's playing. Okay, ready? We think we got it now.
Yeah, I copied all that, Don. Anything else?
There's the scientist for Okay, see this little basket? People go in and out of that. They use that crank to pick them up on, put them on the deck. I guess you do. ship backing up into some broken ice.
How thick was the ice there?
This particular section was about 2 to 3 feet. So sometimes when you're on ice where you're in thick ice, you just hit it and then you back off, hit it again, you back off, and you hit it again. And you'll like this part.
What ship is this?
This is the Sikuliak.
It's brand new?
Yes.
Wasn't it like christened like last year or 2
Yes.
years ago or something? How did
So everyone's wondering why there's so much rust on it.
So
That's what the ocean does.
I got another question.
Yeah.
How did the photographer get there to film that?
Ah. Remember that basket going up on the ice? So they set up a camera. Now it's speeded up. We lost the photographer on this. So an icebreaker cuts ice, breaks through the ice, and right over. That vessel is 260 feet long. That's about as fast as it's going to go. Okay, so now I wanted to go back and a friend of mine works with marine mammals, and up in the Chukchi Sea we have lots of marine mammals. In fact, the largest walrus herd in the world lives in the Chukchi Sea. The largest herd of bowhead whales on Earth use the Chukchi Sea seasonally. We have lots of different seals. And we have wonderful animals called belugas, and I don't think I brought a picture of a beluga. Does anyone know what a beluga looks like? White. Who said white? Right. Great. Good. So you know what belugas look like, okay? So, if you're an animal in the ocean, generally you can't see very far because the ocean water absorbs light. So, you can't see up in the Chukchi Sea, you probably can't see much further than this back road, no matter how good your eyesight is. Okay? But the ocean and water is a great conductor of sound. And animals use sound to communicate with one another. Sometimes they use it to find prey. So I want to just go through and I want you to listen to some animal noises here, okay? Let's do this. Focus. So first one I'm going to play is a bearded seal. And I don't know if you've ever seen a bearded seal, but that's what they look like. They weigh about 750 pounds, and they're about 7 to 8 feet long. And they live for about 25 years. And the females generally have one pup each year. And they eat the food that's on the bottom of the ocean. So they dive to the bottom of the ocean, and they don't go very deep. In the Chukchi Sea, they only have to go 150 feet or so to find dinner. Okay? So we're not talking out in the middle of the ocean where they dive down 16,000 feet to find a plant. So they go to the bottom of the ocean, in the Chukchi Sea, and they root around the bottom, and they get a clam or some kind of a worm, and then maybe on the way up they catch a fish. And then they like to lay around on the ice. Oh, not yet. So let's hear what a bearded seal sounds like. Like to hear that again? No? Is it too scary? Raise your hand if you want to hear it again. All right. Sounds like something you'd want for Halloween. Okay, so let's go and look at another guy.
So that's an underwater sound that he's making?
Those are underwater sounds, yes. Yes, those are sounds that are recorded by tape recorders, if you will, that are put out in the ocean and left there, and then we come back several months later and pick them up and listen to all the sounds that have been recorded. Okay? Yes,
He's probably just doing that for communication with others, or?
yes, I'm unfortunately not the expert on these animals, but I believe in general it's for communication. And then sometimes during mating season, they're very, very active communicators. And then during the rest of the year, when mating is over, they're not really communicating. So you don't even know that they're there unless you see them. Okay. Okay, walrus. Anyone ever seen a walrus?
My mom has.
Yeah. Okay. Especially when you get a whole bunch of them on a piece of ice. It's not white, I will tell you that. Okay, so they are about 9 to 10 feet long, and they weigh about 3,000 pounds, 2,000 to 4,000, depending on if you're male or female. They live for about 40 years, and I think they have about a calf once every other year. That's long. They also eat stuff on the bottom. A lot of stuff on the bottom of the Chukchi Sea. I can hang out up there more than they Chukchi Sea. Okay, so let's take this down. And let's listen to a couple of walrus sounds. This sounds like my family eating. Should we hear that again? That's a walrus. I think they're saying this patch of worms right here is Then they do some other things. This is really wild. There's doors on the bottom of the ocean.
Knocking those teeth on shell.
You know, they probably are using something in air chambers in their mouth or head. Want to hear that again? Okay. Okay, I didn't bring a picture of a beluga. I don't know why I didn't do that. But we're going to listen to a beluga. And this beluga was identified as being about 10 miles away from Point Ley. Does everyone know where Point Ley is? It's about halfway between Bering Strait.
That's where my dad's statue lives.
Oh, okay.
Is halfway between what and what?
It's about halfway between Bering Strait and Barrow on the Chukchi coast, okay? This beluga was 10 miles off Point Ley. There was a mammal recorded there. Should we listen to that once more?
Yeah.
Okay. And then I'll tell you something interesting about beluga. Okay, so belugas are kind of interesting. They pass through the Chukchi Sea. I'm not sure that people really know where the belugas that use the Chukchi Sea go to winter. They come up to the Chukchi Sea in June, and they go by Point Ley, and the people in Point Ley use them as a really important source of food for them. So they hunt the belugas off of Point Ley. The belugas are just passing through, and they go out into the Arctic Ocean. Sometimes they stay right along the edge of the open sea or offshore. And they eat a lot of fish. They eat what's called hardened cod. And but they also do some other interesting things, and scientists haven't figured out why or the purpose of what they're doing. But they also go way out into the middle of the Arctic Ocean, and they put tags on these guys. And they found that they dive down to about 3,000 feet. And they're down there, and the people that do these studies, they have studied these recorders for a long time, and they conclude that they're going down there and fooding. So something down around 3,000 feet appears to be a food source, at least on occasion, for the belugas, which is pretty remarkable. And they go all the way up to the North Pole. So that's a long haul to go find something to eat at 3,000 feet.
Is that the Pacific Ocean before? Is it water from a different source? Would
Well,
it be a different type of microorganism?
At 3,000 feet, it's Atlantic.
Okay.
Okay? All right. So the last one I have is the mighty bowhead. Anyone know what a bowhead is?
Yes.
Yeah? Does it have a bow on its head?
Yes.
There's a bowhead whale. Okay? With a calf. That's a mommy with a calf. Okay? And they're anywhere from 50 to 70 feet, 180,000 pounds. They live for 150 years at least. And they have a calf about every 2 years or so. They eat zooplankton. Anyone know what a zooplankton is?
Yes. They're little tiny creatures that live in the sea.
They're little tiny creatures that live in the sea. That's right. And there is zooplankton. In this case, these guys are called euphausids. And they look like little tiny shrimp. That's right. And you can see they're held in this guy's hands, and there's a quarter on the side there. So that's what bowheads feed on. So this big giant animal is feeding on very tiny little things. So in order for that animal to get enough food, they have to find out where there are clouds and clouds and clouds of these euphausids. And that's one of the things I try to help my friends in biology do, is figure out what are the physical mechanisms that tend to push these euphausids into big aggregations so that a bowhead whale can come through efficiently. So the bowhead is also a very important source of food. Many of the Eskimos that are living along the north slope of Alaska, they hunt them in all along St. Lawrence Island in the north, all along the western coast of Alaska, in Barrow, and over in Kaktovik. Anyone know where Kaktovik is? Water Island? Over by the Canadian border on the Baltic Sea. So a very important food source for the people of the North Slope. So let's give a listen to what a bowhead sounds like. Okay, so what a bowhead does, they overwinter in the northern Bering Sea, down off of St. Lawrence Island, south of St. Lawrence Island, over on the Russian side. And they too come up. They start to make their spring migration northward in May. And they pass Barrow in sometime in May, late April, May, and the people hunt them on the ice right off the Barrow. Then the bowheads go all the way over to Canada, and they stay offshore of the Mackenzie Delta area and the Mackenzie portion of the Beaufort Sea. And in the fall, they come back, and they come back along the north coast of Alaska, and the people at Kaktovik, they hunt them in the fall with boats. Then by September, the whales are largely over by Barrow again, and there's a fall hunt in Barrow. And then they start to head south, but they don't head directly south. Some of them do. Some of them go all the way over to the western Sea on the Russian side, and they come down along the Siberian coast to Bering Strait, and then into the northern Bering Sea where they spend their winters. I do have another set of sounds for the bowhead. So I just want to close by saying that humans don't have such good hearing compared to these animals. These animals can communicate over very long distances, miles and miles. We couldn't hear anything quite like that. And if you're an animal and you're in the ocean, it's a really, really noisy place to be. Because I've only showed you 4 animals. There's a lot of these communicating in the ocean. Not only that, there's a lot of ship traffic, at least in some parts of the world, that generate a lot of sound. And that sound can be a disturbance for these animals, and it can interfere with their ability to hear their mates or others in their species. And I don't have one, but I've heard also sounds that were made in the winter in the Chukchi Sea with the ice moving around. And it's extremely noisy. Another thing that makes a lot of noise is breaking waves. Another thing that makes a lot of noise, believe it or not, is rain on the ocean. In fact, some people are trying to use recordings of noise to estimate how much rain is falling in the ocean. It's a whole other lecture we could go into on sound in the ocean. I don't have time to do that, but I just wanted to leave you with those thoughts. I'd be happy to take any questions that you might have on anything we've talked about.
I have
Yes,
a
sir.
question.
Yes, sir.
Ma'am,
Ma'am, I'm sorry.
how much interference with their lives does the sonograph
Yeah, that can actually be a very big issue. So the seismic profiling that they do, yeah, and the sparker arrays that they stick out. So for those of you that don't know what we're talking about, when geologists are looking at for oil in the ocean, or to understand what the ocean seafloor looks like, they send out sound from a ship. It propagates into the ocean seabed and down deep below that, and it starts to reflect back from different layers of sediment or rock or caverns of oil. And the geologists and the seismologists then use that to interpret what the bottom of the ocean looks like and where there may be good prospects for looking for oil. When they do that, they send a huge amount of sound into the ocean. It's very loud. And there's a concern, and one of the concerns is that it's so loud that it could damage these animals' hearing, or it'll drive the animals away. It'll be something they want to avoid. We do know that it happens. Both, I don't know that we understand the hearing damage that may come about from it as well as we might like to. But I know there's people that are working on understanding that. This young gentleman had a question. Okay. Any other questions?
One here.
Yes, ma'am.
Do you know what the walrus's tusks are for?
Do we know what the walrus's tusks are for?
Calling out on the sea ice.
Hauling out on the sea ice, that's one. Do they fight with them?
Yeah.
They do. I don't think they're used for digging the bottom. Their mouths are like giant vacuum. This is my understanding. Their mouths are like giant vacuum cleaners, and they get on the bottom, and they just start to vacuum up the bottom and take in everything that's buried in the mud. And sometimes the things that are buried in the mud that they like to eat are down 1 or 2 feet. So they are sucking. In fact, you can fly over where walruses are feeding, and you won't see the walrus because they're on the bottom, but you'll see a cloud of muck stirred up by them. Any other questions? Okay, so, oh yes, ma'am.
Are these animals good for food, or what happens with them?
Which animals now?
These various whales?
Yes, yes. Native communities eat walrus, ear seal, beluga, and bowhead. All 4 that I showed, plus several others that I did not show.
But they're not marketed.
They're not marketed. In fact, the only people that can hunt them for subsistence use only, that is for their own use, are Native Alaskans. So I'm going to have one request. I want you, from now on, whenever you see a raindrop or a snowflake, I want you to think about where it came from and where it might have been created. Because the ocean is very much like that. Yes, sir.
I do.
Yeah.
I do. Well, that's all right. I have wondered about, I mean, okay, if they evaporate and go up and then they come down later, it's evaporated, it's kind of pure. So it's not different in one area than another. I'm just wondering about
The rain
the
of the water.
microcosm, and I mean, the microbes in each one.
In
Is
the-
it
in the
really that
raindrop?
different supporting different life?
In the raindrop?
In the, yeah, in the different parts of the ocean.
So when
If we were drinking water that was, originally from Malaysia
yeah,
versus water that had come from a different area, is it different? No.
yes, you can actually use some. There are some chemical signatures that you can use to get an idea
It
of
is
the latitude.
Oh, okay. Yeah, that's what I was wondering.
Okay, thank you very much. Oh, yeah, okay. What's your question there, young man? Bet your mommy would have a chance to ask them that.
But he wanted to ask you, so
Yeah.
there you go.
I think they click their tongue real rapidly, or they have vocal cords that do that. Yeah. But what's amazing is that they can make it pretty loud and they can propagate for a long ways.
You know who we really should ask? Your Aunt Shana.
Yeah. Hi.
Hi. Do you happen to know Stacy Smith?
Yes, I do know Stacy.
Where is she?
Good question. I don't know. She left
12 years ago.
12 years ago now?
I went to her graduation.
Yeah, I don't know. I'm sorry. You know who would know her? No. Do you know Susan Henricks?
No.
Provost?
But I could find out.
Yeah. If you write to Susan, send her an email. She might know.
Thank you.
Short question. Why does the Atlantic Ocean water go down low and is it full of safety? Is that because it's more less salt?
It's colder? Colder. Yes. Yeah. That's why it runs up.
When I go outside and I saw fireworks and then I had snow time.
You went out and saw fireworks in the snow time? Oh my goodness, what a lucky young girl you are.
And they keep it on the fireworks.
Where did you see them? In Fairbanks?
Nope.
Oh,
At my home.
inside your house. Oh. Good. Yes, ma'am.
So, I think I heard something about the temperatures changing. I don't know, the rising ocean levels or whatever, what else any impact to this, but, and salinities, that the currents are changing.
Yes.
Is it the air currents, the water currents, both?
Well, we certainly know that the sea level's rising. And that's rising because glacier fields are melting. Greenland, Alaska, Antarctica, everywhere there's glacier, there's been a net glacial loss. So that's adding. If you warm the ocean water, the water will expand. So that's also causing the sea level to come up as well. Currents are a little bit harder to say whether they're actually changing because